October 8th, 2025. Imagine this. Right now, millions of miles from Earth, a fleet of our most advanced robotic explorers orbiting Mars have swiveled their cameras away from the rust-colored dust of the red planet. They are staring out into the blackness of space, their lenses fixed on something that, according to our understanding of the universe, simply should not exist. What are they seeing? An object, a visitor from another star system, is blazing through our cosmic neighborhood. But this is no ordinary comet. This visitor is actively spewing a torrent of gas and dust into space, a staggering 150 kilograms every single second. Picture the force of that, the sheer violence of such an eruption. It's like watching a colossal cannon fire a continuous, unending shell. Now, what happens when a cannon fires? It kicks back, right? A powerful, immediate recoil. It's Newton's third law, one of the most fundamental principles of physics we learn in school. For every action, there is an equal and opposite reaction. But this object, it shows zero recoil. None. It's a constant, violent explosion with absolutely no consequences. The sight is so fundamentally wrong that when scientists on Earth first received the data, their initial reaction was one of disbelief. They were certain their multi-billion-dollar instruments had to be broken. They ran diagnostics, they checked the code, they recalibrated everything. But the instruments were fine. The data was real. This silent, recoilless cannon was really out there. This object, the third interstellar visitor we've ever detected, is named 3I Atlas, and it has already started to haunt the dreams of astronomers. The legendary and often controversial Harvard physicist Avi Loeb has already placed it at a 6 out of 10 on his scale for ranking potential alien technology. A 6. Not a 0, not a 1, but a 6. That alone should tell you we are in uncharted territory. But that's not the real reason you're here, is it? You're here because the story took a darker, more intriguing turn just a few days ago. Someone, an anonymous source claiming to be a frustrated researcher with the European Space Agency, leaked a series of technical, detailed, and deeply troubled messages on the internet forum 4chan. This leak paints a picture of a scientific community in quiet crisis. The poster describes being part of a formal working group, a team of brilliant minds tasked with one job: make 3I Atlas fit into any known category of natural object. And according to this insider, they have tried and they have failed. The frustration in their words is palpable. They wrote, and I quote, "This position is no longer tenable, and the silence from leadership on the cognitive dissonance this requires is becoming a serious professional issue." Cognitive dissonance. The stress of holding two contradictory beliefs at once, believing the data is real, yet being told to accept an explanation that the data flatly contradicts. What is this data that has them so troubled? It's a cascade of impossibilities. The leak speaks of chemistry that shouldn't be possible. Steaming off this supposedly ancient rock, a relic from the birth of another solar system billions of years ago, is a compound called nickel tetracarbonyl. This isn't some exotic space mineral. It's a synthetic, industrial chemical that we use on Earth in refining processes. How in the universe did a man-made compound get onto a primordial comet? Then there's the dust. The light reflecting from the dust cloud around 3I Atlas is so strange, so far outside the norm for any known comet or asteroid, that the team apparently spent a full week convinced their equipment was malfunctioning before they were forced to accept the bizarre measurements as real. And perhaps most unsettling of all is the mass problem. All that outgassing with no recoil implies a truly staggering mass, at least 33 billion tons. The weight of a small moon, somehow compressed into a body no more than 3 kilometers across. The statistical odds of an object this massive being the third interstellar traveler we find are, to put it mildly, astronomical. The numbers are so bad that they present us with a stark choice. Either our models of how the galaxy works are wrong by a factor of 10, 0, or this thing isn't just a piece of interstellar debris at all. But here's the detail that turns this from a scientific puzzle into a genuine mystery thriller. In just 26 days, 3I Atlas will disappear. It will slip behind the sun, completely hidden from every single telescope we have on Earth or in orbit. This blackout provides the perfect cover, a hidden window of time. And when it emerges again in December, we will be watching for one crucial thing. Did it change course? Because if it did, even slightly, then no natural explanation can account for it. There is a theory, a wild one, that sounds like it was ripped from the pages of science fiction. But it's a theory that explains every single one of these anomalies. The impossible outgassing, the synthetic chemistry, the thermal mystery, the mind-boggling density. It's the theory of an object with its own internal engine, a power source not fueled by the faint warmth of our sun, but by something left over from the Big Bang itself. And the most incredible part, this theory is testable. It makes two specific falsifiable predictions, both of which we will have an answer to within the next 3 months. This is the story of 3I Atlas, the first interstellar object that has forced sober, serious scientists to question whether they are looking at a comet or something merely pretending to be one. By the end of our journey today, you will understand why some of the world's top researchers are no longer sleeping well, why its trajectory looks unnervingly like it was designed, why the timing of its arrival is just a little too perfect, and what happens next if the data continues to refuse to cooperate. The walls of our understanding are cracking, and for the first time, we are starting to see the true shape of the room. So if you're ready, let's begin this story. A story that is happening not in the past, but in real time right now. Something incredible is happening right now. Not tomorrow, not in a history book, not in some far-flung future scenario where we finally build the right kind of telescope. It's happening today, October 3rd, 2025. As we speak, humanity has a small armada of sophisticated spacecraft positioned in orbit around Mars. The Mars Reconnaissance Orbiter, Mars Express, the ExoMars Trace Gas Orbiter, these are our robotic eyes and ears at the fourth planet. For years, their mission has been to gaze downwards, to map the canyons, plains, and polar ice caps of Mars. But today, they have abandoned that mission. Today, every single one of them has turned its gaze outward, into the cold, silent void of interplanetary space, attempting to photograph the same mysterious object, 3I Atlas. Just this morning, at 4 o'clock Universal Time, this interstellar wanderer made its closest pass to any planet during its entire journey through our solar system, coming within a breathtaking 29 million kilometers of Mars. Why is this moment so critical? Let me explain. For the past 3 months, ever since its discovery, our most powerful eyes on Earth have been watching 3I Atlas. The Hubble Space Telescope captured its ghostly image. The magnificent James Webb Space Telescope, with its giant golden mirror, tasted its chemical signature from across the solar system. Dozens of observatories, perched on mountaintops from Chile to Hawaii, have tracked its every move. But there's a fundamental problem with all of that data: distance. When Hubble took its portrait of 3I Atlas back in July, the object was 446 million kilometers away. That is a gulf of space so vast, it is almost impossible to comprehend roughly 3 times the distance between the Earth and the Sun. At that range, even Hubble's legendary vision can only reveal so much. It saw a fuzzy, indistinct blob, a nucleus shrouded in a glowing cloud of dust and gas. But today, everything changed. The Mars Reconnaissance Orbiter, armed with its phenomenal high-resolution imaging science experiment, or HIRISE camera, is now 20 times closer to 3I Atlas than Hubble was. Just imagine that for a moment. 20 times closer. The leap in potential clarity is staggering. Where Hubble saw a smudge of light, HIRISE should be able to resolve details down to just 30 kilometers per pixel. If this object is truly as large as some of the initial calculations suggested, a behemoth 5 kilometers or more in diameter, we shouldn't just see a dot. We should see structure. We should see its shape. We might even glimpse features on its surface. The European Space Agency is a key player in this cosmic stackout. Their two spacecraft, Mars Express and the ExoMars Trace Gas Orbiter, have also pivoted their advanced instruments toward the comet. These probes were designed to photograph the Martian surface in stunning detail, but for this brief, precious window of opportunity, they are aiming at something far more alien. And then there are the spectrometers. These aren't your typical cameras. Instruments like Omega and Nomad don't just take pictures. They are masters of light. They act like prisms, breaking down the faint light reflected from 3I Atlas into its constituent wavelengths, its fundamental rainbow of colors. That data is a treasure trove of information. It reveals chemistry. It tells us what molecules are present in that outgassing plume, what temperatures exist on its surface, and it could help us answer the biggest question of all. Is the activity we re-seeing driven by simple ice turning to vapor the way a normal comet works? Or is it being powered by something else entirely? The official hope, the line you'll hear in the press releases, is that these new up-close observations will finally settle some of the basic questions. How big is the nucleus really? Is it rotating? And if so, how fast? What does that mysterious dust cloud actually look like when you're right next to it? And most importantly, is this just an unusually large and hyperactive comet, or is there something fundamentally, profoundly different about this object? Because here's the tension, the central paradox that has scientists so captivated. Based on its brightness when it was first discovered, astronomers initially estimated that 3I Atlas could be up to 20 kilometers wide, the size of a major city. Then, as better data poured in from the Vera Rubin Observatory, that estimate was revised down to 10 kilometers. Hubble's observations in late July suggested a smaller figure, maybe 5.6 kilometers. And some models, depending on how reflective or dark its surface is, suggest it could be as small as 440 meters across. That is a massive, almost absurd range of uncertainty. It's the difference between a sprawling metropolis and a single large skyscraper. And the answer to this size question matters. It matters a lot. If 3I Atlas is confirmed to be on the larger end of that scale, say 5 kilometers or more, it instantly becomes the most massive interstellar object ever detected, outweighing the previous two by several orders of magnitude. To put this into perspective for you, our first interstellar visitor, the bizarre, cigar-shaped object known as Oumuamua, was estimated to be only about 100 meters long. The second, 2I Borisov, was a more familiar-looking comet, perhaps 600 meters across. But a 5-kilometer object weighing 33 billion tons? That isn't just big. It's statistically problematic. Our current models of how planetary systems form and how they eject debris into the galaxy are built on a simple principle. Small things should vastly outnumber large things. For every single mountain-sized rock like 3I Atlas that gets flung out from a distant star, there should be tens of thousands, maybe hundreds of thousands, of pebble-sized fragments. It's simple probability. You should find the common, smaller objects first. Yet here we are. We have detected exactly 3 interstellar visitors so far. And the third one we find is potentially 1,000 to 1,000,000 times more massive than the first 2. That's completely backwards. It's like panning for gold and finding a solid gold boulder on your third try. It forces you to question your assumptions. Unless our models are completely wrong. Unless the galaxy isn't just sparsely dotted with interstellar debris, but is positively swarming with it. Unless the way solar systems eject material is fundamentally different than we ever imagined. Or unless this object isn't debris at all. That is the profound question these Mars observations are supposed to help answer. If the HiRIC camera captures a clear, unambiguous image of a 5-kilometer nucleus, then the 33 billion ton mass estimate becomes a hard fact, and the statistical anomaly becomes an unavoidable crisis in astrophysics. If, on the other hand, the image shows something much smaller, say a kilometer or less, then the mystery simply changes its shape. A smaller nucleus producing such an immense, bright cloud of gas and dust would mean the object is extraordinarily, unnaturally active, venting far more material than any known comet at that vast distance from the sun. Either way, something doesn't add up. Now, here's the frustrating part for all of us waiting on the edge of our seats. We won't know the answer immediately. This precious data has to be carefully transmitted across millions of miles of space back to Earth. It has to be processed, analyzed, cross-checked by teams of scientists. The European Space Agency has already tried to manage expectations, stating publicly that they don't anticipate spectacular images. Their orbiters, after all, are designed to look down, not out. At 30 million kilometers, 3I Atlas will appear as less than a single pixel in their main cameras. They might capture the halo of gas around it, maybe a hint of the tail, but they won't see the nucleus itself. The HIRISE camera is our real hope for a definitive portrait. And even then, the timeline is uncertain. It could be days, maybe even weeks, before processed images are released to the public. And in that information vacuum, the object keeps moving relentlessly on its predetermined path. By mid-October, 3I Atlas will be too close to the sun to observe from Earth. The blinding glare of our own star will make it completely invisible. It will reach perihelion, its closest point to the sun, on October 29th, and during that entire period, it will be on the opposite side of the sun from us, hidden, unobservable. That's 26 days of radio silence. And when it finally re-emerges into our pre-dawn sky in early December, we will finally be able to see it again, to check its trajectory, and to learn if it behaved like a normal comet during its fiery passage, or if something unexpected happened while it was hidden from our view. But let's bring it back to today, to this Mars moment. Because while the official narrative is all about resolving the question of its size, there's another, deeper layer to this story. A layer that has less to do with what the cameras might capture, and more to do with what the data we already have has shown us. And that, my friends, is where things truly start to break. Just as our robotic probes at Mars were maneuvering into position for their historic photoshoot, a bombshell dropped back here on Earth. Avi Loeb, the audacious and often polarizing physicist from Harvard, published an article. The timing was no accident. On the exact same day as the Mars flyby, he laid out with chilling precision what he calls the 7 anomalies of 3I Atlas. Notice his choice of words. These aren't mere curiosities. They aren't just scientific puzzles. He calls them anomalies, behaviors, and characteristics that refuse to fit into the standard, comfortable model of what an interstellar comet should be. He methodically divided them into 2 categories. The first contains 4 mysteries that, in theory, could be solved or at least softened with better data, the very data we are hoping to get from Mars. But the second category contains 3 anomalies that, in his stark assessment, will likely remain puzzling forever. Why? Because they aren't about missing information. They are about probabilities. They are about a trajectory and a timing so exquisitely perfect that they seem to whisper of something more than just random chance. Let's begin where science is most comfortable, with the potentially explainable mysteries. Anomaly number 1 is its sheer size. As we've discussed, the current estimates place the diameter of 3I Atlas at over 5 kilometers, giving it a minimum mass of 33 billion tons. Just try to wrap your mind around that. It makes it 1,000, perhaps even 1,000,000 times more massive than the previous 2 interstellar objects we've seen. The hope is that today's flyby will give us a clear picture and a final number. But this is a double-edged sword. If the nucleus turns out to be much smaller, the anomaly softens. though it creates a new one about its incredible activity. But if it's confirmed to be 5 kilometers or larger, the statistical crisis deepens. The problem of finding a golden boulder on your third try becomes an undeniable fact. Anomaly number 2, the jet. Hubble's images revealed a truly peculiar feature, a long, narrow jet of scattered sunlight, 10 times longer than it is wide, pointing directly toward the sun. This is bizarre. Anyone who has seen a picture of a comet knows that their tails are supposed to stream away from the sun, pushed back by the solar wind and the pressure of sunlight. But this jet is aimed in the completely opposite direction, like a spear of light pointed at the very star it's approaching. The conventional explanation is that 3I Atlas is having a powerful outgassing event on its sunward side, releasing a plume of material that catches the sunlight before it gets blown back. And that's plausible. But here's the catch that keeps astronomers up at night. This powerful jet appeared very early, at a vast distance from the sun, where most comets are still frozen and dormant. And it has remained unusually bright and persistent. A weaker, more normal tail did eventually show up, but only much later. That delay is deeply weird. It suggests the engine driving this activity is not behaving like a typical, simple comet. Anomaly number 3 is where things get genuinely strange. Its chemical composition. When the James Webb Space Telescope and the Very Large Telescope analyzed the light from the gas cloud around 3I Atlas, they found a chemical fingerprint unlike any we've ever seen. The plume contains far more nickel than iron. In every normal comet we've ever studied, nickel and iron appear in roughly the same ratio as they do in our sun. They are cosmic cousins, always found together. But 3I Atlas shows an extreme dominance of nickel. Why does this matter? Because nickel and iron are tough metals. They don't just turn into gas at the frigid temperatures found on a comet, hundreds of millions of kilometers from the sun. For raw nickel to simply boil off its surface is a thermal impossibility. Something else must be happening. The official theory is that there must be a mysterious parent molecule, some unknown compound containing nickel that breaks down under sunlight. But what is it? And there's more. Most comets are rich in water. It's the sublimating water ice that drives their activity. But 3I Atlas is profoundly water poor. Instead, it's dominated by carbon dioxide. The ratio of CO2 to water is 8:1, among the highest ever recorded. This suggests it was born in a place far colder than the regions where our own solar system's comets were formed. Anomaly number 4 is a technical one, but it's critical. Polarization. When sunlight bounces off dust particles, the light becomes polarized. By measuring that polarization, scientists can tell you about the size, shape, and texture of the dust. Think of it as a way of feeling the dust from 1 billion kilometers away. And every single comet and asteroid we have ever studied falls within a certain predictable, consistent range. 3I Atlas does not. The data came back so far outside the expected range that the research team initially declared it must be an error. They reran the measurements, they checked their instruments, and the same impossible result came back. The only way to make the numbers work is if the dust grains being shed by 3I Atlas are fundamentally different from any natural dust we've ever seen. They aren't typical silicate sand or water ice crystals. The data implies they are large, incredibly complex particles, highly porous, with a structure almost like smoke. Now, here's the key. These 4 anomalies are deeply strange, yes, but they aren't necessarily fatal to the comet hypothesis. Better data might clarify the size. The jet could be a rare but natural asymmetry. The nickel could come from some exotic parent molecule we just haven't discovered yet. The dust could be the product of some unusual formation conditions in its home star system. Uncomfortable, yes, but perhaps, just perhaps, explainable. Then we get to the second category, the permanent mysteries, the ones that no amount of new data can ever explain away. Anomaly number 5. The trajectory's alignment. The planets in our solar system orbit the sun on a relatively flat plane, like marbles rolling on a dinner plate. We call this the ecliptic. Interstellar objects, arriving from random directions in the galaxy, should have random orbital inclinations. Some should dive in from the top, some from the bottom, some should go backwards. The probability that a random visitor would just happen to arrive on a trajectory that is aligned with our planetary plane to within 5 degrees, just by pure chance, is about 0.2%. That's 1 in 500. Not impossible, certainly. Rare events happen, but it is the first bright red flag that something is amiss. Anomaly number 6 is where the probability plunges off a cliff into the realm of the impossible. Arrival timing. 3. Atlas didn't just arrive on a path aligned with the planets. It arrived at the exact time that allows for a series of close encounters with Mars, Venus, and Jupiter. Think about the celestial mechanics involved. It's a cosmic billiard shot of unbelievable precision. The probability of an interstellar object randomly arriving on a trajectory, and at a time that allows for such a planetary grand tour, is about 0.005%. 1 chance in 20,000. Let that sink in for a moment. If you were an engineer at NASA designing a probe to visit multiple planets, you would want a trajectory that efficiently intersects their orbits. You would time your arrival to coincide with their positions in space to minimize the fuel needed for course corrections. This is exactly how we design our own most ambitious missions, like Voyager and New Horizons. You optimize the trajectory. You use gravitational assists. You plan every step with surgical precision. And 3I Atlas looks, for all intents and purposes, like its trajectory was planned. It looks less like it stumbled into our solar system, and more like it was delivered. If the story ended there, with a 1 in 20,000 cosmic longshot, it would already be one of the most compelling scientific mysteries of our time. A grand celestial coincidence. But 2 days ago, the story took a sharp, dramatic turn. It left the hallowed halls of academia, the peer-reviewed journals, and the official press releases, and plunged into the murky, chaotic depths of the Internet. On October 1st, 2025, an anonymous post appeared on 4chan. Not in a science forum, not on a preprint server where physicists debate new theories. It was posted on the Paranormal Board, a digital space more known for ghost stories and internet folklore than for legitimate scientific discourse. And yet, this was not folklore. This was something else entirely. The poster claimed to be a PhD researcher, a scientist actively working with the European Space Agency. They said they had direct, ongoing access to the combined observational data for 3I Atlas from multiple instruments. More than that, they claimed to be a member of the formal internal working group, the team of experts whose job it is to make sense of this visitor. And then they made a stunning confession, that the group had failed. For months, they wrote, they had been locked in a professional struggle, trying and failing to reconcile the object's bizarre behavior with any known class of natural celestial body. The frustration, the sheer intellectual exhaustion, bleeds through the text. I want you to hear their words directly, because they are chilling. Quote, "The official position is that 3I Atlas is a uniquely active, but otherwise natural comet. This position is no longer tenable, and the silence from leadership on the cognitive dissonance this requires is becoming a serious, professional issue for a growing number of us. Now, let's be absolutely clear. An anonymous post on 4chan is not, and should not be, considered peer-reviewed science. It isn't verified. It could be an elaborate and clever fiction, a role play by someone who has read all the public papers and decided to stir the pot of speculation. That is the rational, skeptical position to take. But here's what makes this different. What makes the hair on the back of your neck stand up. The level of technical detail in the post is extraordinary. The frustration in the tone feels painfully genuine. and the claims it makes align disturbingly well with all the publicly available data, while adding a layer of behind-the-scenes context that hasn't appeared in any official release. It feels like someone has finally opened a window into the quiet, frantic conversations that are happening when the cameras are off. So, I'm going to walk you through what this person said, not as established fact, but as a possible glimpse into what happens when brilliant scientists stare at data that simply refuses to cooperate. The post begins with the problem of outgassing. We know 3I Atlas is venting approximately 150 kilograms of gas and dust every single second. This isn't speculation. It's a hard measurement from the James Webb Space Telescope and confirmed by spectrometers on the ground. The object is hemorrhaging material into space. And according to this researcher, this constant violent eruption does nothing. Absolutely nothing. Here is how they describe the sheer wrongness of it. It feels like a mistake in the data until you've vet-checked it 100 times with all the available instruments. The object is venting about 150 kilograms of gas and dust every single second. We see it, yet it does nothing. It's like watching a howitzer fire a shell with absolutely zero recoil or smoke or bang. It's a constant violent event with no consequences. And that is a disgusting violation of basic physics. Let me explain exactly why that is such a profound problem. When a comet heats up and releases gas, those plumes of vapor act like tiny rocket engines. It's Newton's third law in action. For every action the gas jetting away from the surface, there is an equal and opposite reaction. The comet recoils, getting a tiny push in the opposite direction. It's a very small push, yes, but over days and weeks and months, it's measurable. Astronomers call this non-gravitational acceleration. It's a slight deviation from a purely gravitational path, a tiny wobble that tells us the comet's jets are firing. Every active comet we have ever observed shows this. The legendary Halley's Comet, the magnificent comet Hale-Bopp, even our previous interstellar visitor, 2I Borisov, all of them displayed a clear, measurable non-gravitational acceleration as they outgassed near the Sun. 3I Atlas shows almost none. The data is so clean, its trajectory so perfect, that it appears to be moving under the influence of gravity alone, as if it were a dead, inert rock. A detailed paper published just last month analyzed over 4,000 positional observations from 227 observatories. They were specifically looking for this deviation, and the upper limit they found was so impossibly small, it was essentially zero. For an object venting 150 kilograms of material per second, this shouldn't be possible. The only way the physics works, according to the anonymous poster, is if the object is far, far more massive than it appears. Quote, "The only way the physics works is if the object has the mass of a small moon crammed into a space no more than 2 to 3 kilometers across. This is the only way it could be massive enough to resist the recoil from its own violent outgassing. The lower-end models already give us a floor of 33 billion tons, which solves the physics problem, but, as the insider states, just creates a second worse problem. Think about what that means. To solve the violation of Newton's laws, you have to accept that 3I Atlas is incredibly, unnaturally dense. Far denser than ice, denser than any rock, approaching the density of solid iron. A 3-kilometer sphere of nickel iron would have roughly that mass. But this isn't a simple metallic asteroid. It has a coma, a tail. It's outgassing volatiles like a comet. So the mass has to be there, but it also has to somehow coexist with ices on its surface. It's a paradox wrapped in an anomaly. But this is where the insider's logic takes its most terrifying leap. They point out that our surveys of the sky for interstellar objects have only just begun. We are cosmic infants, just starting to look around. To find an object this massive, this soon, fundamentally breaks our understanding of the galaxy. Finding a mountain on an interstellar trajectory is statistically impossible. They write. To find an object this massive this soon means the galaxy isn't just dotted with debris, it's swarming with them. Pause here. Let that sink in. If the mass estimate is correct, if this 33 billion ton object is real, then our statistical models of the galaxy are not just a little bit wrong. They are catastrophically wrong. It would mean that for some reason, the universe is far better at producing and ejecting massive, planetoid-sized objects than small, pebble-sized ones. The entire pyramid of our understanding would be inverted. It would mean our whole conception of how planetary systems form and evolve is built on a foundation of sand. That is one possibility, a complete revolutionary upheaval of astrophysics. But the insider presents the alternative, the other side of the coin, the quiet and terrifying conclusion they claim they are being discouraged from discussing. Quote, or this object isn't debris at all. If the story of 3I Atlas were a courtroom drama, the case against it being a natural object would now move to forensic evidence. After the shocking testimony on its physics-defying motion, we now turn to the chemistry, to the very atoms and molecules that make up its ghostly plume. And according to the anonymous insider, this is where the mystery deepens into a genuine nightmare. Their post argues that the chemistry doesn't just bend the rules, it shatters them. You look at what's actually in the gas, it gets worse, they write, their tone a mixture of awe and horror. We're seeing pure atomic nickel steaming off. It's happening at temperatures where it should be frozen solid. Let's unpack that statement, because it is truly bizarre. When the Very Large Telescope in Chile pointed its powerful ultraviolet spectrograph at 3I Atlas, it detected the faint glow of nickel atoms, not nickel compounds, not nickel-laced dust, but pure individual atoms of nickel, present every single time they looked. Here's the problem. Nickel is a refractory metal. That's a scientific way of saying it's tough. It has a melting point of 1,455 degrees Celsius. To boil it into a gas of individual atoms requires a staggering 2,913 degrees. At the vast distance where 3I Atlas was observed, its sunlit surface would be colder than an Antarctic winter, somewhere between -100 and -50 degrees Celsius. At those temperatures, nickel should be nothing more than a frozen inert solid, locked within the rock. For it to be steaming off into space is like watching an ice cube in your freezer spontaneously boil. It's a complete violation of thermodynamics. The official scientific papers acknowledge this puzzle, of course, but their language is cautious, measured. They suggest the existence of a mysterious parent molecule, some unknown, volatile organic compound containing nickel that, when touched by sunlight, breaks apart and releases the nickel atoms. It's a plausible, if unproven, hypothesis. But they don't and can't name what that molecule might be. Why? Because in nature, nickel is chemically stoic. It doesn't like to form the kind of volatile compounds that would be needed. It prefers to stay solid. The alleged insider, however, does not hesitate. They name the molecule directly. And in doing so, they deepen the mystery tenfold. The only option, they claim, is a chemical called nickel tetracarbonyl. For chemists, this name is instantly recognizable and deeply troubling. It's an organometallic compound 1 nickel atom bonded to 4 carbon monoxide groups. On Earth, it's a colorless, highly toxic, and highly volatile liquid. Crucially, it is photosensitive. Expose it to the ultraviolet light that the sun bathes our solar system in, and it rapidly decomposes, leaving behind pure nickel atoms. This would perfectly explain the observations from 3I Atlas. It would explain the nickel appearing at impossible temperatures, and it would explain why the amount of nickel production is so insanely sensitive to sunlight. As the insider notes, a tiny change in heat and the nickel production just shuts off. The process isn't driven by heat, but by light, a photodissociation process, just as you'd expect from nickel tetracarbonyl. So, the chemistry fits like a glove. But here's the terrifying, multi-billion-dollar question. What the hell is a synthetic industrial chemical doing on a rock that we think has been drifting through interstellar space for billions of years? Nickel tetracarbonyl doesn't occur naturally on Earth. It was discovered in a laboratory in 1890. We use it in a specific industrial technique called the Mont process to purify nickel metal. It is, for all intents and purposes, a man-made compound. How did it get out there? Could it form naturally in the unique conditions of a protoplanetary disk around another star? Perhaps, but even if it could, it's incredibly unstable. It breaks down over time, especially when exposed to the harsh radiation of deep space. An object that has been traveling for eons, bathed in cosmic rays, simply shouldn't have any intact nickel tetracarbonyl left on its surface. Unless it's not ancient. Unless it's being actively and continuously produced right now. Which raises an even stranger question. Produced by what? The insider then pivots to the second chemical anomaly, the dust. And the dust it's shedding is just as messed up, they write. We've already touched on the bizarre polarization data, the measurements that were so far off the charts that the science team thought their instruments were broken for a week. The insider adds chilling context to this. Quote, "The only way to get these numbers is if the dust grains are something else entirely, not sand, not ice, large, incredibly complex particles. Black and porous as smoke. This is not natural dust. It's a manufactured material. A manufactured material. Think about what that implies. Natural comet dust is typically made of tiny, simple grains of rock and ice, blasted off the surface by sublimating gas. But the dust from 3I Atlas is different. The data suggests it's made of large, fluffy, complex aggregates, almost like soot or an aerosol. This is the kind of material you get from complex chemical processes, like combustion or chemical vapor deposition, where particles are built up atom by atom. It is the kind of dust you'd expect to find in the exhaust of an engine, not sublimating off a primordial ice ball. And then they deliver the final devastating summary of the forensic evidence. The chemistry is wrong. The physics is wrong. It's a perfectly self-consistent system of wrongness, as though its whole purpose is to make us doubt ourselves. That phrase, a perfectly self-consistent system of wrongness, is haunting. It suggests that these aren't just a collection of random, unrelated anomalies. They are symptoms of a single underlying cause. Each paradox, each violation of the rules, is another law. And as the insider powerfully concludes, we're all standing here staring at the walls, refusing to see the shape of the room. This isn't a failure of our models, they argue. This is something far more profound. This is a glimpse of the machinery running underneath them. And whatever that machinery is, it is not natural. Every object in the vast emptiness of space spins. It's an unavoidable cosmic law. Over billions of years, the gentle tug of gravity, the impact of micrometeorites, the subtle pressure of starlight, every tiny interaction imparts a little twist, a little nudge of angular momentum. Rotation isn't the exception. It is the default state of the universe. So, when astronomers discover a new object, one of the very first things they do is try to measure its rotation. They watch its brightness over time, looking for a rhythm, a pulse. As an irregular, lumpy object like a comet tumbles through space, different parts of its surface, bright patches of ice, dark patches of dust, jagged peaks, and deep craters, rotate into view. This causes its brightness to fluctuate, creating a periodic wave of light. We call this its light curve. It's one of the most basic, fundamental measurements in observational astronomy. It tells us how fast the object is spinning and gives us clues about its shape. It is the object's heartbeat. 3I Atlas, according to the anonymous insider, does not have one. Its light curve is a dead flat line. We've stared at it for days on end, they write, the exasperation clear in their words. Its brightness doesn't change. Not by a fraction of a percent. This isn't just unusual. It is profoundly, fundamentally wrong. Even a perfectly smooth, featureless sphere would show brightness variations if it were outgassing from a specific spot. And we know 3I Atlas is outgassing. We've seen the evidence. That bizarre, sunward-pointing tail. The only way to explain the tail is with a powerful directional jet of gas and dust firing from its sun-facing side. It's a violent, localized event. But if you have a violent, directional engine firing from one side of a rotating body, it should create a strobe effect. As the jet rotates into our line of sight, the object should get brighter. As it rotates away, it should get dimmer. It should flicker. It should have a rhythm. We see absolute, perfect, unwavering stillness. The insider frames this as an irreconcilable paradox. Quote, "The explanation for the tail requires a violent directional event. The observation of its light requires a perfectly uniform cloud. You can't have both. One is a lie. This is a brilliant and brutal piece of logic. Either our model for what's creating the tail the jet is wrong, or the cloud of gas and dust we are seeing isn't natural. Is it possible that the outgassing is perfectly symmetrical, happening equally in all directions at all times, like a slowly evaporating sphere? That would explain the constant brightness, but it completely fails to explain the forward-pointing tail. A symmetrical outflow would create a symmetrical coma, not a directional jet. Is it possible the dust cloud is so incredibly thick that it's acting like a smokescreen, hiding the flickering of the nucleus within? Perhaps, but the data we have suggests the cloud is relatively thin. This leaves us with a truly unsettling possibility, that the object is somehow actively regulating its brightness, maintaining a constant reflective surface regardless of its rotation. It's a suggestion that sounds absurd, like something out of science fiction, but it's one of the only ways to reconcile two completely contradictory sets of observations. And for the insider, this isn't a separate problem. It's part of the same system of wrongness, the same underlying machinery that makes the outgassing recoilless and the chemistry synthetic. And that machinery, they argue, is not being powered by the sun. It's being powered by something internal. This brings us to the next ghost in this machine, the thermal problem. The heat. 3I Atlas is currently absorbing gigawatts of raw solar energy. That's not an estimate. It's a simple calculation. For an object of its size at its distance from the sun, it is soaking up enough energy to power a small city. That energy has to go somewhere. In a normal comet, the heat energy is used to sublimate ice-turning frozen water, carbon dioxide, and other volatiles from a solid directly into a gas. This process is a fantastic heat sink. It's how comets stay cool, by venting that absorbed energy back into space in the form of gas. It's a simple, elegant system of energy balance. Energy in equals energy out. But with 3I Atlas, the books don't balance. According to the leak, the thermal models are broken. We calculate the energy budget, and there's a massive surplus. They write, the object is absorbing gigawatts of power, but it isn't releasing a corresponding amount of water vapor, the primary coolant for most comets. We know this from the James Webb Space Telescope, which found it to be extremely water poor. So, if the energy isn't being used to sublimate water, where is it going? Is the object just getting hotter and hotter? No. The spectroscopic data tells us the surface is cold, far colder than it should be for a dark object absorbing that much sunlight. The thing is cold, the insider writes with a sense of disbelief. It's like pointing a blowtorch at an ice cube and watching it refuse to melt. The object is absorbing gigawatts of power. It's not releasing the expected amount of coolant, and it's staying unnaturally cold. The energy is simply disappearing. Into what? Into where? The post suggests a radical idea, that the object has found a way to either dispose of or regulate its enormous thermal load, to keep its surface locked at a specific low temperature. That word again, regulate. It implies active management, a system, not the passive physics of a dead rock. What could possibly do that? The insider's conclusion is both terrifying and strangely logical. They argue that the gigawatts of energy from our sun are a trivial external variable to a monstrous ancient object that has its own internal power source. It radiates the sun's heat away passively and indifferently, they suggest, because the sun is not part of its life cycle. It has an engine inside. And if that's true, then the thermal regulation isn't a mystery at all. It's a consequence. The object doesn't need our sun. It is utterly indifferent to it. Which raises the most disturbing and profound question of all. If 3I Atlas has an internal power source, what in the universe could it possibly be? We have now arrived at the heart of the mystery. The central, unifying theory that the anonymous insider claims is the only physics that makes the cascade of impossible data coherent. This is where the story takes a breathtaking leap from the realm of observational astronomy into the deepest, most speculative frontiers of theoretical physics. It's a concept that sounds, at first, like pure science fiction. But according to the researcher, it is the only key that unlocks every single paradoxical door we've encountered. Quote, "It is a macroscopic quantum object," they begin, "a stable, massive particle left over from the first microseconds of the Big Bang, a bubble of a different set of physical laws that has managed to survive, cloaked in a skin of our reality." The name for this theoretical engine, they state, is a non-topological solitone, but it has a much simpler, catchier nickname, a Kubal. This isn't a theory, the insider asserts with stunning confidence. It is the only known physics that makes the data coherent. So, what is a Kubal? Let's take a quick journey back to the very beginning of time. In the first fractions of a second after the Big Bang, the universe was an unimaginable inferno of energy and density. The fundamental forces of nature that we know today, gravity, electromagnetism, the strong and weak nuclear forces, were all merged into a single unified superforce. The particles we know, quarks, electrons, photons, had not yet condensed out of this primordial soup. As the universe rapidly expanded and cooled, it went through a series of violent phase transitions, like water freezing into ice. In these transitions, the superforce broke, separating out into the distinct forces that govern our reality. But just as when water freezes, the process might not have been perfect. It might have been messy. Theoretical physicists have long predicted that this cosmic freezing could have left behind effects, cosmic fossils from that first moment of creation. These could be one-dimensional flaws, called cosmic strings, or point-like monopoles. Or they could be three-dimensional, stable bubbles where a pocket of that ancient, unified, high-energy state got trapped. That bubble, a stable, massive lump of primordial energy held together by a conserved quantum property. The Q stands for charge, is a Q-ball. Think of it as a tiny, fossilized piece of the Big Bang, wrapped in a skin of our normal reality that has been wandering the universe ever since. Now, this is highly speculative physics. Q-balls are predicted by certain advanced theories, like supersymmetry, but they have never, ever been observed. Most physicists consider them an interesting but unlikely hypothetical. Except, the insider claims, 3I Atlas fits the profile of a Q-ball perfectly. Let's walk through their logic, because if they are right, it solves everything. First, a Q-ball would have enormous mass in a tiny volume. They are, by their very nature, super-dense objects. A Q-ball just 3 kilometers across could easily contain the mass of a small moon 33 billion tons or more. This perfectly matches the minimum mass required to explain the shocking lack of recoil from its outgassing. The howitzer with no kickback is no longer a paradox. It's a direct consequence of the object's incredible density. Second, a Q-ball is its own engine. The primordial high-energy field trapped inside is not perfectly stable. It decays, but it does so incredibly slowly, releasing a steady, constant stream of energy over billions of years. This energy would radiate outwards from the core, heating the material that has accumulated around it over the eons, a thick mantle of ice and dust collected during its long journey through the galaxy. This internal heating would cause the ice to sublimate from the inside out. This explains the object's intense activity so far from the sun. It doesn't need the sun's heat. It has its own furnace. Third, this inside-out heating would produce perfectly isotropic outgassing. The energy is released uniformly in all directions from the core. The gas would therefore escape symmetrically from all sides of the object at once. No jets, no directional thrust. The outgassing would be perfectly balanced, with every action on one side being cancelled out by an equal and opposite action on the other. This elegantly explains why we see a violent 150 kilograms per second outgassing with zero net recoil. Newton's third law isn't being violated. It's being perfectly, symmetrically satisfied. Fourth, this isotropic outgassing would create a perfectly uniform, spherically symmetric cloud of gas and dust. This immediately solves the mystery of the dead flat-like curve. If the cloud surrounding the object is a perfect sphere, then it doesn't matter if the core is rotating. It will look exactly the same from every angle. The brightness never flickers because there is no asymmetry to rotate into and out of view. Fifth, the exotic chemistry. A cue ball's decay is not a chemical reaction or a thermal process. It's a high-energy particle physics event. It's a quantum reactor. Over billions of years, this slow, steady burn could produce all sorts of exotic biproducts complex molecules. Metallic carbonyls like nickel tetracarbonyl, and the manufactured smoke like dust. These aren't natural compounds from a protoplanetary disk. They are the exhaust fumes of an ancient primordial engine. Sixth, thermal indifference. If an object has its own internal multi-gigawatt power source, the feeble warmth of our sun would be, as the insider puts it, a trivial external variable. The object's surface temperature isn't determined by absorbing and radiating sunlight. It's regulated by the constant, steady output from its core. It stays cold because its internal engine is a low-temperature, high-efficiency quantum process, not a blazing furnace. Finally, the trajectory. If cue balls are real, they might not be rare at all. Some theories propose that they could be a component of the mysterious dark matter that makes up 27% of the mass of the universe. If that's the case, then the galaxy isn't just dotted with a few ejected rocks. It is literally swarming with these ancient, massive objects. 3I Atlas isn't a statistical freak. It's just the first one we've been able to see. It's not debris from a distant star. It is a fundamental piece of the cosmic population, a relic from the Big Bang itself. That would explain why we found something this massive so quickly. We weren't looking at a rare piece of planetary shrapnel. We were looking at dark matter made visible. The Insider summarizes this stunning hypothesis with a powerful statement. The cue ball is the mass. Its engine is its own decay. The lack of recoil is no longer a paradox. It's a defining feature. This is not a matter of belief. This is the only known physics that makes the data coherent. Once you look at it, the entire system of wrongness snaps into a logical, horrifying picture. Horrifying. Not intriguing, not exciting. Horrifying. Why that word? Because if 3I Atlas is a cue ball, it means that dark matter isn't just some inert, invisible dust scattered between the stars. It's active. It's composed of massive city-sized objects. And it's everywhere. The galaxy is swarming with ancient, decaying primordial engines. And if that's true, it changes everything we thought we knew about the universe we live in. The cue ball hypothesis is a breathtaking, mind-bending idea. It feels like it belongs in an Arthur C. Clarke novel. But here is the most crucial, most scientific part of the anonymous insider's entire post. This is not just a wild story. It's a testable, falsifiable scientific hypothesis. It makes specific, concrete predictions about how 3I Atlas should behave in the near future predictions that are completely different from how a normal comet should behave. The post ends with a challenge, a call to action for the entire scientific community. Quote, "Screen cap this." It's a bold, confident statement, essentially daring the universe to prove it wrong. And it lays out two clear, unambiguous tests. The first prediction concerns the object's activity as it moves away from the sun. Every comet we have ever observed is a slave to the sun. Its behavior is driven entirely by solar heating. As it gets closer, the ice on its surface sublimates more violently. Its coma brightens, and its tail grows longer. As it recedes back into the cold depths of the outer solar system, the activity drops off precipitously. The outgassing slows, the brightness fades, the comet dies down. This relationship between distance and activity is a universal, predictable law of cometary physics. But if 3I Atlas has its own internal engine, if its activity is powered by a cue ball's steady decay, then it shouldn't care about the sun. Its activity won't follow that predictable curve. The insider predicts that as 3I Atlas recedes from the sun, past the orbit of Mars, past the asteroid belt, its brightness and mass loss rate will remain impossibly, unnaturally high. It will, in their words, violate the thermodynamic expectation for a passive cooling body. This is a clear, testable prediction. We can simply watch. When the object re-emerges from behind the sun in December, we will have months to observe it as it travels outwards. If it fades away as expected, the cue ball hypothesis is likely wrong. But if it stays stubbornly, defiantly bright, if that 150 kilograms per second outgassing continues unabated into the cold darkness, that would be a smoking gun. Comets simply don't do that. The second prediction is even more dramatic. It concerns high-energy emissions. The decay of a cue ball, remember, is not a chemical process. It's a particle physics event. According to the insider's own rough estimate, this engine could be producing around 73 megawatts of power. That energy doesn't just create heat. It should produce a shower of high-energy particles, gamma rays, and X-rays. It should have a non-thermal, high-energy signature that would be utterly alien to a simple comet. The prediction is therefore simple and direct. Point a gamma-ray telescope at it, the post commands. If you detect a signal that is not attributable to solar-wind interaction, you're not seeing a comet. You're hearing the heartbeat of an object that doesn't follow our rules of physics. This is also perfectly testable. We have powerful gamma-ray observatories in orbit, like NASA's Fermi and ESA's Integral, that are constantly scanning the heavens. So far, there have been no public reports of a detection from the location of 3I Atlas. But that doesn't mean it isn't there. These signals are incredibly faint, and data analysis takes time. A detection might not be announced immediately. Or it could be sitting in an archive right now, a ghostly whisper of high-energy light waiting for someone to find it. If that whisper is ever confirmed, it would be a game-changer. No natural comet in our solar system emits gamma rays from internal processes. Only the most extreme objects in the universe do, collapsing stars, supermassive black holes, pulsars, or, if this hypothesis is correct, a fossil from the Big Bang. Now, it is absolutely essential to pause here and inject a strong dose of scientific skepticism. This is not mainstream science. The cue ball hypothesis is on the furthest fringes of theoretical physics. Most astrophysicists would, and do, dismiss this idea outright. It is exotic. It is speculative. It requires you to accept that dark matter takes a form. We have never detected that the early universe produced stable macroscopic quantum objects, and that one of them just happens to be passing through our solar system right now. The simpler explanation, the one favored by Occam's razor, is that 3I Atlas is just a weird comet. An outlier, to be sure, with unusual chemistry and bizarre dust, but still fundamentally natural and ultimately explicable within our current understanding of planetary science. That is the official conservative position, and in science, The conservative position is usually the right one. But if the leaked post is genuine, if it truly reflects the private struggles of a real ESA working group, then it means that behind closed doors, the cue ball hypothesis, or something very much like it, is being discussed. Not as the most likely answer, but perhaps as the only alternative on the table that doesn't require willfully ignoring half of the observational data. And if those two predictions come true, if 3I Atlas stays bright as it leaves, and if a gamma-ray signal is detected, then the conversation will change with the speed of light. The fringe theory will suddenly become the leading contender. The impossible will become the probable. And the entire world will have to confront a new and astonishing reality. We are about to find out. The universe is about to show its hand. In just 26 days, 3I Atlas is going to perform the ultimate vanishing act. It will do something that, from our perspective here on Earth, should make everyone a little nervous. It's going to disappear. Not literally, of course. The object will still be there, a 33 billion-ton behemoth coasting silently through the void. But for us, its audience, the curtain will fall. Starting around October 24th, the object will slip into the blinding glare of our own sun. From that moment until early December, it will be completely invisible to us, swallowed by the light. For nearly 6 weeks, every telescope on and off this planet will be blind to it. And right in the middle of that blackout period, on October 29th, 3I Atlas will reach perihelion, its closest, fastest, and hottest approach to the sun. The moment of maximum stress, the moment a normal comet would be at its most spectacularly active, will happen entirely behind closed doors, where we cannot see it. This timing has not gone unnoticed. In his October 3rd article, Avi Loeb pointed out this celestial coincidence with mathematical precision. The probability of a random interstellar object reaching its perihelion at the exact time it is hidden from Earth's view is roughly 7%. That's about 1 in 14. Not impossible, but certainly not a random chance you'd bet your life on. And here is where the story takes a turn into the realm of strategic possibility, into a line of thinking that feels more like military intelligence than astronomy. If 3I Atlas were not a comet, but a spacecraft, if it had propulsion, if it could maneuver this hidden window at perihelion, would be the single most optimal moment to do so. Specifically, it would be the perfect time to perform a maneuver that rocket scientists call a reverse Oberth burn. Let me explain what that means, because it's a fascinating piece of physics. The Oberth effect is a core principle of orbital mechanics that our own space program uses all the time. In simple terms, it states that a rocket engine is most efficient when your spacecraft is already moving at its highest speed. Firing your thrusters at your fastest point gives you the most bang for your buck, the biggest change in your kinetic energy. It is why we perform our most critical burns to escape a planet's gravity when our probes are at their closest approach, their periapsis, where they are moving fastest. That's a standard Oberth maneuver. A reverse Oberth maneuver is, as the name implies, the exact opposite. Imagine you are a spacecraft screaming into a solar system on a hyperbolic trajectory, destined to swing around the star and fly right back out into interstellar space. But you don't want to leave. You want to stay. You want to be captured into a stable orbit. The most fuel-efficient way to do that is to fire your engines in reverse at perihelion, at your point of maximum velocity. You brake. You dump energy at the most efficient moment possible, and your trajectory changes from an escape path to a closed, elliptical orbit. You go from being a visitor to a resident. If 3I Atlas wanted to remain in our solar system, October 29th would be the absolute best moment to hit the brakes. And it would all happen conveniently behind the sun, completely hidden from our prying eyes. Loeb frames this possibility with his characteristic, carefully worded audacity. He isn't claiming it will happen. He is simply pointing out that the orbital mechanics are, shall we say, convenient. Quote, This could be intentional, he writes. To avoid detailed observations from Earth-based telescopes when the object is brightest, the optimal point for a reverse solar orbit maneuver to become bound to the Sun is at perihelion. It is this optimal breaking point for 3I Atlas that is obscured from our view by the Sun. He even takes it a step further, raising a possibility that is even more unsettling. What if the main object is just a mothership? He uses the word gadgets, small probes released from the main body, taking advantage of the close planetary encounters to reach Mars, Venus, or Jupiter with minimal fuel. The calculations for this have already been done. To send a small probe from 3I Atlas to Mars during this week's CES flyby would require a change in velocity of less than 5 kilometers per second. That's well within the capabilities of our own chemical propulsion, comparable to the thrust of an intercontinental ballistic missile. The same is true for Venus and Jupiter. It's a highly efficient trajectory for a planetary reconnaissance mission. And who is the one planet that gets skipped in this initial low-energy pass? Earth. A mission profile might read, visit the other, less populated planets first. Gather data from a safe distance. Then decide if the third planet, the one with the bustling technological civilization, is worth the higher energy cost of a closer look. Again, this is pure, informed speculation. But it's speculation grounded in the hard math of orbital mechanics. And here's the key. We will know if it happened. We just have to be patient. When 3I Atlas finally reemerges from behind the Sun in early December, the very first thing every observatory on the planet will do is take its picture, measure its exact position, and calculate its new trajectory. If the orbit is identical to the predictions, if the object is exactly where it's supposed to be based on a purely gravitational path, then we can all breathe a sigh of relief. Nothing happened. It was just a comet, albeit a weird one, that passed by and is now on its way out. But if the orbit has changed, if there is any deviation, no matter how small, that cannot be explained by natural outgassing, then something happened back there, in the darkness behind the Sun. The object either maneuvered, or it fragmented, or it experienced some other event that changed its path. And that would be a discovery that would shake the foundations of science. We have a date for this moment of truth. Loeb has identified a critical 2-week window, from November 21st to December 5th. If a maneuver happened at perihelion, the resulting change in its trajectory should become clearly detectable by then. For 2 weeks, the world's astronomers will be watching, waiting to see if 3I Atlas keeps its appointment with destiny, or if it has made other plans. Just when you think the labyrinth of possibilities surrounding 3I Atlas can't get any deeper or more bewildering, another door opens onto a corridor of thought that is perhaps the most unsettling of all. The idea came not from Avi Loeb himself, but from one of his collaborators, a gentleman named Omar Dar. He proposed a theory within a theory, a speculation so audacious it borders on the paranoid, yet possesses a chilling strategic logic. What if 3I Atlas, with all its spectacular anomalies and headline-grabbing physics, is a distraction? What if this entire celestial drama is a grand piece of cosmic misdirection, a decoy designed to draw all of our telescopes and all of our attention, while the real operation happens somewhere else entirely? Loeb discussed this decoy scenario in a blog post, framing it as a fascinating thought experiment. Quote, my collaborator Omar, Dar suggested that aliens might use a natural-looking interstellar comet as a decoy to attract our attention when they conduct another operation at a different location near Earth. It has a classic magician's trick. Focus the audience's attention on the big, flashy object in the right hand, while the left hand performs the subtle, secret work. In this scenario, while the entire world is obsessing over the strange comet with the impossible physics, what might be happening closer to home, right here in our own atmosphere, in our own orbit? Are there smaller objects, quieter and stealthier, doing things we aren't noticing because we are all looking the other way? Now, this might sound like pure conspiracy theory, but here's the twist. This is a testable hypothesis. And someone is testing it right now. The Galileo project, Loeb's own privately funded research initiative, was designed for precisely this kind of search. It's not looking for radio signals from distant stars. Its mission is to systematically and scientifically search for evidence of extraterrestrial technology right here, in our own backyard. The project has 3 advanced observatories in Massachusetts, Pennsylvania, and Nevada, each one a sophisticated suite of high-resolution cameras, infrared sensors, radar, and audio detectors. They scan the entire sky 24/7, recording everything that moves. An advanced AI system then sifts through this mountain of data, classifying every object it sees: birds, planes, satellites, meteors. Most of it is mundane, easily explained. But the system is designed to flag the anomalies, objects that move too fast or change direction in ways that defy conventional aerodynamics. The project has been running for a few years, and it is watching. And according to Loeb, it will be watching with extreme vigilance throughout October and November, precisely when 3I Atlas is hidden behind the sun. He has, in essence, laid a trap. He has publicly predicted that if the decoy hypothesis is correct, we should see an enhanced activity of unidentified anomalous phenomena, UAPs, in the Earth's atmosphere during this period. So, if strange things start appearing in our skies, while 3I Atlas is in its blackout window, the Galileo project is designed to catch them. A sudden spike in unexplained objects, a statistical anomaly clustering around late October and early November, that would be a deeply intriguing correlation. It wouldn't prove the theory, of course. Correlation is not causation. But it would be a piece of data so strange, so timely, that it would be very, very hard to ignore. This leads to another related idea, a concept that feels like it has been pulled directly from the golden age of science fiction, the stealth hybrid spacecraft. What if an advanced civilization, wanting to travel between the stars, wouldn't build their ships from scratch? What if, instead, they used natural materials? What if they found a large asteroid or comet, hollowed it out, and built their machinery inside, using the natural, rocky exterior as the perfect camouflage and radiation shielding? This concept, proposed by a reader of Loeb's work, is both elegant and terrifyingly practical. An asteroid hull provides excellent natural protection against the harsh environment of interstellar space cosmic rays, micrometeorites. It offers inherent stealth. From the outside, as long as it's not actively firing engines or showing artificial lights, it would look just like a natural, dead rock. Think about it. We see this idea in our own fiction, from Arthur C. Clarke's Rendezvous with Rama to Greg Bear's The Forge of God. A massive, technological object disguised as a natural asteroid or comet. It's a familiar trope, but it's also a deeply logical engineering solution to the immense challenges of interstellar travel, and it makes detection incredibly difficult. Astronomers are trained to assume that rocks are just rocks. Unless an object does something overtly, unambiguously artificial, like sending a radio signal or making a sharp right turn, it gets classified as natural. 3I Atlas has done nothing obviously artificial. It has simply behaved in ways that are deeply, persistently wrong according to our understanding of natural physics. The chemistry is off, the motion is off, the trajectory is suspicious, but none of it is definitive proof. And that is the absolute brilliance of a stealth hybrid design. It is perpetually, deniably ambiguous. You can't prove it's artificial without getting up close, and by the time you could launch a mission to do that, it would be long gone, back into the interstellar dark. So we are left with these haunting questions, hovering in the background of the main investigation. Is the Galileo project going to see a spike in strange activity in our skies in the coming weeks? Will UAP reports from around the world suddenly increase? And if they do, Will anyone be brave enough to connect them to the silent visitor passing behind our sun? Or will October and November pass with an unnerving quiet, with no anomalies, no uptick, just the silent passage of a very strange comet? The data will provide the answer, one way or another. We just have to be willing to watch and to listen, and to consider that sometimes the most important part of the show is not what's happening in the spotlight. Beneath the surface of the official statements and the carefully worded scientific papers, a fracture is forming. The scientific community, a body that prides itself on consensus and methodical progress, is quietly fracturing over the enigma of 3I Atlas. This isn't a loud public debate happening in press conferences. It's a quieter, more profound division happening in the spaces between the lines in email chains between trusted colleagues, in hushed conversations in conference hallways, in late-night debates over freshly processed data. Two camps are emerging, and the intellectual chasm between them is widening with every new, baffling observation. On one side, you have the establishment, the defenders of the conventional model. Their position is rational, conservative, and grounded in decades of planetary science. 3I Atlas, they argue, is a comet. Yes, an unusual one, a spectacular outlier that is pushing the boundaries of what we thought was possible. But it is still, fundamentally, a natural phenomenon. The bizarre chemistry? It can be explained by some exotic, yet to be identified parent molecule. The shocking mass estimates? They are likely wrong, a product of flawed assumptions about its brightness and composition that better, closer data will eventually correct. For this camp, the anomalies are not evidence of the impossible, but simply a reflection of the limits of our current knowledge. The universe, they remind us, is a vast and varied place, and it is bound to show us things we've never seen before. The solution is not to leap to extraordinary conclusions, but to be patient, to be rigorous, and to trust that the scientific method will, in time, resolve these puzzles within the existing framework of natural law. On the other side of the chasm is a smaller, more cautious, but growing camp of scientists who are less certain. They are looking at the exact same data, running the same calculations, and they are arriving at answers that simply do not fit. The problems, as they see them, aren't just at the edges of the model. They are at its very core. The physics doesn't work unless you are willing to accept premises that seem, on their face, to be impossible: the incredible density of a small moon, the existence of an internal energy source, the presence of synthetic industrial chemistry. The leaked 4chan post, if it is to be believed, is the authentic voice of this second camp. The official position is no longer tenable, the insider wrote, and the silence from leadership on the cognitive dissonance this requires is becoming a serious professional issue. That phrase, cognitive dissonance, is a powerful psychological term. It describes the profound mental stress of trying to hold two contradictory beliefs at the same time. In this case, the belief that the data is accurate and reliable, and the simultaneous belief that the object is natural. Because if the data is right, the natural explanation doesn't fit. And if the natural explanation is right, the data must be fundamentally wrong. But the data has been checked, rechecked, and independently verified by multiple teams using different instruments. It keeps coming back the same. So where does that leave the researchers who find themselves trapped in this logical vice? According to the Post, they are being subtly, professionally discouraged from discussing the more radical alternatives. Not censored, not forbidden, but discouraged. This is a real and powerful force in the culture of science. The professional incentives are always aligned with the conventional explanation. A paper that proposes a new type of exotic comet will have a much smoother ride through peer review than a paper that cautiously suggests the possibility of non-natural origins. A grant proposal that uses standard astronomical terminology is far more likely to be funded than one that mentions words like artificial or technosignature. Careers can be built on cautious incremental progress, and they can be stalled or even damaged by a reputation for being too speculative, too out there. Most of the time, this institutional conservatism is a healthy and necessary check on wild speculation. It keeps the field grounded. But occasionally, in the face of a true black swan event, it can create a dangerous blind spot, a situation where the data is pointing insistently in one direction, while the entire community is resolutely looking in another. This tension is not new. Jason Wright, a respected astronomer at Penn State, has been a vocal critic of what he sees as Avi Loeb's tendency to jump to alien explanations too quickly. He argues that Loeb's claims get a lot of media attention, but often do not hold up to rigorous scrutiny. Wright points out, for example, that the idea that the object's fuzzy appearance is just image smearing is incorrect. Modern professional observatories are more than capable of tracking moving objects without blurring. If multiple independent observations show a coma, he argues, then it has a coma. That makes it a comet. End of story. But Loeb's position is more nuanced than that. He is not claiming certainty. He is proposing a framework for dealing with uncertainty. He created the Loeb scale, a 0 to -10 ranking system, to move the conversation away from a simple binary, is it alien or not, and toward a more sophisticated question, how anomalous is it? On this scale, 0 is definitively natural, and 10 is definitively artificial. He currently rates 3 High Atlas at a 6. Not a 10, not even an 8. Just a 6, an object that is anomalous enough to warrant a serious, dedicated investigation into the possibility of an artificial origin. He has even gone so far as to propose that this scale be formally adopted by an international body, perhaps even the United Nations, to create a standardized protocol for how we as a species respond to these interstellar visitors. The idea is to have a pre-planned, coordinated international response ready to go, so that when the next one arrives, and with our new observatories, we know it will, we won't waste precious time debating what to do. The plan is ambitious, perhaps even bureaucratic, but it is a serious attempt to grapple with a serious new reality. We are no longer alone in our knowledge of other star systems. Pieces of them are now coming to us, and we are at present completely unprepared. As the silent debate rages on in the background, the object itself continues its inexorable journey, and the clock is ticking. We are now entering the most critical phase of the investigation, a period of a few short months where data, not debate, will write the next chapter of this story. A series of crucial observations are about to take place, each one a potential key that could unlock the mystery or deepen it even further. The waiting is almost over. The race for answers has begun. First, and most imminently, are the images from Mars. Within days, perhaps a week, the first pictures from the Mars Reconnaissance Orbiter's flyby should be processed and released. This is our best and only chance for a close-up portrait of the nucleus. What that portrait reveals will be a major fork in the road. If the images show a clear, large nucleus, 5 kilometers or more in diameter, then the mass problem becomes an undeniable crisis. The 33 billion ton estimate becomes a hard floor. The statistical anomaly of finding such a massive object so soon will be an unavoidable fact that will force astrophysicists back to the drawing board. It would mean that either interstellar space is far more crowded with massive objects than our models predict, or that this object is exceptional in a way we simply do not understand. But what if the opposite is true? What if the images reveal a much smaller nucleus, a kilometer or less across? That doesn't resolve the mystery. It just transforms it. A small nucleus producing such a titanic, bright cloud of gas and dust is a different kind of physical impossibility. It would imply an object that is hyperactive beyond all known limits, an object with a staggeringly efficient internal heat source that is driving these emissions far beyond what simple solar warming could ever achieve. Either outcome, large or small, raises profound, uncomfortable questions. Neither outcome provides an easy answer. At the same time, the spectroscopic data from the European Mars Express and ExoMars orbiters will add another layer of chemical detail. They measured the gas composition from a much closer vantage point, using instruments finely tuned for atmospheric analysis. Will they confirm the bizarre nickel-to-iron ratio seen from Earth? Will they detect other, even stranger compounds that were invisible from a greater distance? A chemical fingerprint of 3I Atlas is about to get a high-resolution update. Then there is the ongoing vigil from Earth. Until mid-October, when 3I Atlas disappears into the sun's glare, every clear night is a precious opportunity. Teams of astronomers around the world are frantically collecting every photon they can, building a detailed, continuous timeline of its behavior, its brightness, its spectrum, its polarization. This timeline will become a crucial baseline. When the object re-emerges from behind the sun in December, they will compare its new behavior to its old behavior. Does it follow the predictable power law curve of a normal comet, fading as it recedes from the sun? Or does it defy that law? The cue ball hypothesis, with its prediction of constant, internally driven activity, will face its first major test. By January or February of next year, we should have a definitive answer to that question. Meanwhile, a quieter, invisible search is also underway. The gamma-ray observatories Fermi and Integral are our eyes for the most energetic phenomena in the cosmos. Their data is being scoured for any hint of a high-energy signal coming from the precise location of 3I Atlas. A confirmed detection of gamma rays that cannot be explained by natural interactions would be, without exaggeration, one of the most significant discoveries in the history of science. It would be the sound of an engine where there should only be silence. And finally, there is the slowest, most patient test of all, gravity itself. Mars is a planet we know with incredible precision. Its orbit is one of the most accurately mapped paths in the solar system. If the 33 billion-ton mass estimate for 3I Atlas is correct, its close pass this week should have given the red planet a tiny, almost imperceptible gravitational tug. That tug will cause Mars to drift, ever so slightly, off its predicted path. The deviation will be tiny millimeters per day, but it is cumulative. Over the coming weeks and months, that tiny drift will add up. By early 2026, if the effect is real, it should be measurable by our planetary tracking systems. This would be independent, unambiguous confirmation of the object's massive nature, a confirmation that has nothing to do with confusing models of brightness or chemistry. It would be the pure, clean voice of gravity itself. And gravity never lies. Each of these threads, the Mars images, the ongoing spectroscopy, the gamma-ray search, the orbital mechanics, is a separate investigation. But their results will not be separate. They will converge. Over the next 3 to 4 months, these disparate lines of evidence will begin to weave together, forming a single, coherent tapestry of understanding. The puzzle pieces are on the table. The data is streaming in. And we are about to see, for the first time, the true picture of what 3I Atlas really is. We find ourselves at the end of a story that hasn't truly finished yet. We are living in the middle of it, in the tense, quiet moments between the climax and the revelation. October 3rd, 2025. The historic Mars flyby has already happened. The data is on its way back to Earth, and locked within those bits and bytes is, perhaps, an answer, or at the very least, the beginning of one. Let's take a breath, step back, and reflect on the extraordinary journey we have taken. We have met 3I Atlas, the third interstellar visitor, an object that has systematically refused to behave. It fires a 150 kilogram per second cannon of gas and dust with no recoil. It packs the mass of a small moon into a body no larger than a city. It steams a synthetic, industrial chemical at temperatures where it should be frozen solid. Its dust is so alien that scientists initially thought their own instruments were broken. It appears to be a violent, active comet, yet it has the unwavering dead-flat light curve of a dead rock. It absorbs the energy of a power station, and yet somehow stays cold. And its trajectory, its timing, its perfect alignment with the planets, all sit at probability levels that should make any rational statistician profoundly uncomfortable. We have seen the 7 anomalies, the 7 sins against the nature of comets. And we have heard the whisper from the inside, the anonymous, unverified, yet chillingly detailed account from someone claiming to be on the European Space Agency team that has tried and failed to make this object fit. We have seen their portrait of a scientific community in a state of quiet cognitive dissonance, discouraged from discussing the terrifying conclusion that maybe, just maybe, this isn't debris at all. We have contemplated the cue ball hypothesis, a wild, fantastic, yet strangely coherent theory of a macroscopic quantum object from the Big Bang, an ancient engine that explains every single paradox. A theory that, most importantly, is testable, with 2 falsifiable predictions whose answers we will have in a matter of months. We have stared into the hidden window, that 26-day period of darkness when the object will pass behind the sun, at the perfect moment to execute a hidden maneuver. We have considered the decoy theory, the unsettling possibility that this loud, spectacular object is just a distraction, while the real reconnaissance happens closer to home. And we have seen the fracture lines forming in the scientific consensus, the growing gap between those who insist it must be a natural comet and those who admit the data simply doesn't fit. A proposal is now on the table for a United Nations Committee on Interstellar Objects, a global framework to ensure that next time we are better prepared. Because there will be a next time, the Vera Rubin Observatory, now scanning the skies with its powerful eye, guarantees it. Soon, interstellar visitors will not be a once-in-a-decade event, but a regular occurrence. And each one will be an opportunity or a warning. 3I Atlas is currently rated a 6 on the Loeb scale, high enough to demand our most serious investigation, but not high enough to trigger emergency protocols. But that number is not static. If the predictions hold, if gamma rays are detected, if the trajectory changes, that rating will rise. And the conversation will escalate from the quiet halls of science to the corridors of power. We are on the verge of learning something fundamental. In the next 3 months, data will arrive that will either gently guide us back to a conventional explanation or force us, irrevocably, toward the extraordinary. The Mars images will reveal its size. The December trajectory measurements will reveal if anything happened in the darkness behind the sun. The gamma ray search will find a signal, or it won't. And by the spring of next year, when 3I Atlas makes its final planetary pass by Jupiter, we will have a comprehensive data set enough to say with some confidence what this thing is, or at least what it is not. The universe does not lie. It can be subtle. It can be coy, but it does not hide its secrets forever. If 3I Atlas is just a comet, a bizarre, freakish, once-in-a-civilization comet, but a natural one, nonetheless, the data will eventually converge on that answer. The anomalies will be resolved, the models will be updated, and science will move on, enriched and expanded by the encounter. But if the data continues to refuse to cooperate, if every new observation only adds another layer of strangeness, if that perfectly self-consistent system of wrongness persists and deepens, then we have no choice but to follow where it leads, no matter how uncomfortable the destination. Because that is the ultimate promise of science. Not comfort, not certainty, but a relentless, fearless pursuit of the truth, however strange that truth may turn out to be. Thank you for staying with this story, for looking into this profound mystery with open eyes and an open mind. Something is out there, moving through the darkness. And in a few short months, we will all know a little more about what it is.